So I hope you don't mind some of the technological creativity that I'm going to be sharing on this post since it's late anyways. I don't know if I'm going to be getting any points here, but one of the things that we have in pharmacy that we use pretty frequently in terms of determining the right dose, making sure that the patient's getting the right amount of medication, is we use a lot of ratio and proportion, fractions and decimals, and it essentially boils down to just working with fractions and being able to keep proportions the same. So really rudimentary, talking about if we have one thing for every two things, then it stands to reason that if we have four things, then we need to have two things per those four other things. And the way that we figure that out is we solve this algebraic line equation to make sure that the total value remains constant on each side. So, for example, if we have a dose that needs to be given to a patient, and the dose is supposed to be 500 milligrams, and that is going to be delivered in 100 milliliters of any kind of volume, let's call it normal saline, then if we want to give them 1,000 milligrams, for example, the question then becomes how many milliliters of vehicle or normal saline are we going to be providing to that patient in order to ensure that they get all 1,000 milligrams. And so at this point, all that we have to do is we cross multiply and divide here. So we're going to cross multiply. And so here we have x times 500, and we end up with 500x. And we will make that equivalent to 1,000 times 100. Seems like a really long number, very tricky. Just go ahead and take the first number of each total value and multiply those, and you get a 1. And then at that point, you just have to add the zeros. So we end up with 100,000 at this point. You can see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And so now at this point, we need to solve for x. So in order to solve this line equation, we'll just go ahead and divide by 500 on each side so that we can isolate x. And so now we get x is equal to, and 5 goes into 10 twice. And then we cancel out the rest of the zeros that we can. And what we're left over with is x is going to be equivalent to 200 milliliters of normal saline. And you can just take a look at the root problem up here and determine whether or not that actually makes sense. So, for example, 500 milligrams is half of 1,000 milligrams, or 1,000 milligrams is double of 500 milligrams, much in the same way that 200 milliliters is equivalent to 100 milliliters. And that is how we determine how much of a volume we need to give to a patient that contains a particular drug. Hope that this provides some insight into what it is that we do every time that we are filling a medication. We're not just counting by fives and putting a label on it, if you couldn't believe it.